assembling our matrix was dominated by figuring out where to store the entry in the matrix. So we had some kind of mapping from multi-indices to where it should be stored in the matrix. Doing that mapping, figuring out where to put this thing, which pigeonhole to put in, was dominating the cost. I would bet a fair amount of money that nobody has ever had that problem with high-order finite elements before, because the cost of getting the entries is so big that you don't worry about putting it away. You've computed it, put it away, you don't see it. That was dominating our cost, just the evaluation of where to put it, and then finding the right part of the memory. So then we had to go away, and to actually demonstrate the optimal complexity, we had to figure out a fancy way that we could kind of step through memory with a big stencil, so that we were always just putting the entries in the next part of memory. So we had to do some fancy partitioning thing that allowed us, when we've got the entries, to just put them in the next place in memory, and this thing stepped through. So I was giving this talk one time, and the question at the end was, you're doing all this thing, but this is a big disadvantage because you've got to do all these fancy techniques for storing it afterwards. The point is that if your code is so fast at evaluating all the other things that that's your bottleneck, then you're doing pretty well. So it can be sorted out, but that's an indication of how fast it is. So in 4D, we're getting the matrix of around about, 10, 20, 30, 40 in around about, 2 minutes. And this is not on a supercomputer, this is on a laptop. So you're invited to try and do better than that. Whatever basis you like, try and get a better constant. You can't get a better complexity, but maybe you can get a better constant. I would be interested to see whether you can do it, because I think it is very difficult to do. Okay, so fine. That seems to be the advantage of using Bernstein polynomials, one advantage. But of course, this is all for H1 approximation. More interesting problems, I have to approximate in HDiv, HCurl,